Hi everyone, welcome back. In this video, we'll see the concept of overlays. Guys, overlays is one of the memory allocation technique which is used at the contiguous memory allocation technique. Guys, if you are able to remember the earlier classes, I started with the memory allocation techniques. These are actually classified into two types. One will be contiguous memory allocation techniques, another one will be non-contiguous memory allocation techniques. In contiguous memory allocation techniques, we have seen one of the technique called partition technique. In this partition technique, we discussed again two kind of partitions. One will be static, another one will be a fixed, right? So sorry, this is not the fixed one, right? Static partition, or I can call it as a fixed partition, or I can call it as MFT, that you remember. Coming to another way, we call it as a variable partitioning, or I can call it as dynamic partitioning. In static partitioning, we discussed one will be partitioning based on all are equal size, another one will be unequal size, and also we discussed for all the things how the performances will be, right? So if we go with the equal partitioning, what about the performance issues, like especially with respect to fragmentation? There will be an internal fragmentation existed for the equal partitioning, am I right? And if it existed internal fragmentation, definitely there might be external fragmentation too. And coming to unequal partitioning of fixed size, internal fragmentation is going to be decreased. Is it true? Yes. There might be some situations where it might fit. See, compared to having all the process with the size 5, 5, 5, definitely we are going to get internal fragmentation, right, which is more. As it is more, external fragmentation is going to be more. Coming to the other way of fragmentation, which is of type unequal, means 1 will be 2, 3, 4, 5. If I got some size 4, definitely it can fit here. So internal fragmentation is going to be reduced in unequal fixed partitioning, and external fragmentation might be increases compared to the equal partitioning. Am I right? Yes. Try to observe the variable partitioning. In variable partitioning, what about the internal fragmentation? Definitely there is no internal fragmentation because it is going to cut as per our need. What about the external fragmentation? Yes, it is there. When external fragmentation is there, we come across with two solutions. One will be compaction, another one will be non-contiguous memory allocation techniques, that we will see in the further videos, right? So this is what we will see in the further videos. But anyhow, we completed the compaction concept where we will try to combine two non-contiguous memory free spaces into one location so that I can able to fit the larger process, right? But the problem here is what? The compaction is going to take more time. That's why we'll move for the solution called non-contiguous memory allocation technique, where you can go with the techniques called something like paging and some kind of concepts called segmentation, virtual memory. All these are the examples that will come under non-contiguous memory allocation techniques, right? So here the thing is, we have to concentrate on this particular area. When you are going to have unequal fixed partitioning, external fragmentation is going to be more, right? So then what will be the solution, right? So the solution will be something like a kind of overlays, right? So here, why you are getting the external fragmentation? One reason might be the size of process. Size of process is depend on, I can say, depend on maximum size of partition. Am I right? Yes. Right. So if you are able to understood it clearly, can we able to use this as a point, and can we have certain kind of solution? That is overlays. Guys, overlays means it is not going to completely use the program in the memory, which means if I say there will be a memory of size 100 KB is free now, and outside there is a process which used to execute usually with 200 KB. Now, can this entire 200 KB is able to place in this particular memory space? No, it couldn't possible, right? So which means that is what I am saying. It is not going to completely use the entire program. Instead, it is going to load whatever the process part is required for us, that will be loaded here, and once it completes its task, that will perform unload. Later again it will load the remaining process part which is required for us. This thing we call it as overlay. It is very simple only, but the concept requires how and why we are coming for the overlays concept. It needs to be understood, right? So suppose for example, let me take a simple example so that you can get the clear idea. There will be a kind of an assembler, right? So let me try to read the question. Consider a 2-pass assembler. Maximum size required is 200 KB with the following sizes used. Guys, you know, when you look into a program, the program requires various kind of things. One will be generally as per the here the statements, one will be the symbol table, another one will be the common routine, and while execution there might be contains one if statement, something like that. If this block contains one kind of pass 1 and another one will be kind of pass 2, right? In order to execute the pass 1 I need 70 KB, in order to execute the pass 2 I need to have 80 KB. At any time only one pass will be in use, and both passes always need symbol table and the common routines. If overlay driven is 10 KB, this is important, then what is the minimum size required, right? So means that what they are using the concept of overlays. So in general, try to observe, try to identify why they say that it is maximum of size 200 KB. It is because if you are going to combine the pass 1, pass 2 and symbol table and the routine, it is equal to 200 KB, right? But they are asking for what is the minimum size required instead of having 200 KB. If you are going to use the overlays technique, try to observe the common thing which needs to be required for both pass 1 and pass 2 are symbol table and the common routine. So symbol table and the common routine. What is the size of the symbol table? 30 KB and common routine is 20 KB. As they are using the overlays concept, it's having one extra button called size 10 KB, right? So this is a button on it, right? So this is common for everything, and I have to go with the pass 1. If I go with the pass 1, what is the value you are going to get? 32 50, 60, 130 KB memory space is enough in order to execute this particular pass 1 along with the remaining things. But when you go with the pass 2, 30 plus 20 plus 10 plus pass 2 is 80, you are going to get 140 kb minimum required. Now try to observe. Can I take the 130 kb as the answer? No. It is because if I take 130 kb as the answer, how will I execute the pass 2? Pass 2 requires 140 kb. It couldn't possible to execute the pass 2. That's the reason you have to take the minimum answer as 140 kb. Guys, try to observe. Actually, we required maximum size of 200 kb. But assume that there is not enough space of 200 kb. Instead, we are having only enough size of 140 kb. Now, can the program successfully runs or not? Yes, it is running because of the concept of overlays. Right? If there is no concept of overlays, is it possible to run it? No, it couldn't possible. Right? This was one of the questions which was asked in the earlier gates examination. Right? I hope you understood the concept of overlays clearly. Thank you.